In this experiment, we're going to measure the quantitative relationships involving the concentrations of reactants and products at equilibrium. What we've already done is prepared solutions of Fe3+ at different concentrations. Now, these concentrations that we've prepared already, you'll have to use the flow chart in the lab to find their initial concentrations. We also have solutions of the SCN- ion. Once again, you'll also have to find their respective concentrations. Now, in this lab, what we're going to do is we're going to react 5 mils of solution A, the Fe3+ ion, with 5 mils of the SCN-. They'll form an equilibrium. What we'll do is we'll take a sample of that and measure the absorbance using a spectrophotometer. Once we take the absorbance value, we can use that to find the concentration at equilibrium. Once we know that concentration, we can find the concentration of the respective ions that we've used. From the results gathered, we'll see if there is any relationship that exists between the 3 ions. So let's begin. We first take solution A, Fe3+, and we'll add SCN-. What happens is a reddish-brown color appears. We'll do the same for all 5 test tubes. Remember, the concentrations of the SCN- are the same for all 5 test tubes. What we've done is we've varied the Fe3+ concentrations. Now, when we first look at it, for the naked eye, it's very difficult sometimes to notice a color change. And that's why we have the spectrophotometer. It is able to differentiate the color. So that's just awesome. Okay, we're almost ready. Once we've got all 5 solutions, we'll give them a nice thorough mixing to make sure they're mixed evenly throughout. Then what we're going to do is we're going to take a sample of it, place it into a cuvette, and into the spectrophotometer, and take the absorbance. I'll make that available to you via a table. So let's begin. What we've done is we've already standardized the machine to take an absorbance for this cuvette. It's important to note that we must always wipe. We don't want any fingerprints on it, nor do we want any solutions. Now, it's really important also to rinse the cuvette with each solution. What we'll do is we'll take a little bit, we'll rinse it, dump it into a waste container, making sure we wipe. Then I'd like to fill it up about 3/4 full. Those test tubes just not long enough. So what we'll do is we'll just dump it directly, just being very careful not to spill it. And we want them about 3/4 full. There we go. So that's solution A. We're just going to wipe it clean to make sure it's clean and dry. Excellent. Now we'll place it into the spectrophotometer and we'll read the absorbance. you'll notice test tube A reads 0.56, 0.56. Now we're going to do the same for the other test tubes. Absorbance reading now for the final test tube B is 0.20, 0.20. Now, it's not a very difficult lab. It's actually quite simple. Now you'll find the hardest part to this lab is doing all the calculations. Please pay extreme attention to finding the initial concentrations after each dilution. Remember, we took the original sample of 0.02 molar Fe3 plus ions and we diluted them. We took a 10 ml sample, added 15 mils to a final volume of 25 mils, diluted it, took 5 mils of that, and that was test tube B. We did the same for C, D, and E.